Let me know when we're good.
We're good.
We're good? Okay. This is problem number 3. Similar type. I just want to model another one. And this says Mr. Kurth is looking through seismograph readings. Seismograph, as you know, is the device that measures earthquakes, how big they are. From the 1906 earthquake in San Francisco, Charles Richter, you all are familiar with the Richter scale. In 1935, defined the magnitude of an earthquake. He said M, the magnitude, equals log base I over S. Where I is the intensity, S is the standard intensity as it says in the problem, 0.0001, and M is the magnitude. And the question asks us, the 1906 earthquake had a magnitude of 8.3, so this is going to be 8.3. And the question is, what is the intensity? So we know 8.3 equals log of I over S. 8.3 equals log of I over S. We know what S is. We can just replace that. So on the next line, I'll write 8.3 equals log of I divided by 0.0001. I divided by 0.0001. How do I solve this problem? How do I solve this? Daniel, what do you think?
You first do the log.
Okay.
You multiply by 0.00.
How do you, what do you mean by do the log? Sorry, I don't know the
Put the base 10 to the, raise it to 8.3.
Okay. And that equals what? No, sorry, in the equation. What comes next?
I over 0.0001.
Yeah. And now I'm going to multiply both sides by 0.0001 because I want I by itself. I'm trying to solve for that. 0.0001 times 0.0001. So this goes away here. So I'm left with I equals this. This can be done on the calculator. And I got 19952.623. And this is measured in centimeters. And the only way you knew that was because when we gave you the S, it said it was in centimeters. S was a standard intensity, so this intensity must also be in centimeters. These.
Does it have to be to like to the 1,000?
3 decimals? Yeah, have to. And if your calculator does not display 3 decimals, you need to come after class and we need to change the settings. Because we will count off tomorrow, on Friday's quiz, we will count off on the exam and we will count off on the common assessment. Daniel.
Would you ever solve for S?
No, because S is just a number that is given. It's always 0.0001, always. Okay. Let's look at the next one. So the next one says, part B. Part B says, the strongest earthquake ever recorded occurred the same year and was 4 times as intense. What was the magnitude? So I'm going to start with my equation. And since I know what S is, 0.0001, I've gotten to here. Now there is a slight problem. I have 2 variables in one equation. This is unsolvable. This is unsolvable. 1.
Wouldn't you use the what you got the I in there, but then multiply the intensity by 1?
Yeah, that's right. It said that the intensity of this earthquake is 4 times as much as the other one. Here's the intensity of the other one. Let's just plug that in here and multiply by 4. So let's go M equals log of, and instead of I, I'll put this, 19952.623 times 4 divided by 0.0001. Now this we can do on the calculator. Multiply these two together, divide by 0.001, then take the log of the answer. Matthew?
Where did you get the 4 from?
In the problem, it says that in B it says the strongest earthquake ever recorded was 4 times as intense.
Okay.
Does that work?
Yeah.
Okay. So I'll get M, and you should verify this on your end. Was I got 8.902. Let's verify. If you didn't get that, please stop me.
Yeah, 8.9.
02. Need to get 3, Josh. You have the 3? Okay, good. Great. Questions? No. So this one is not in centimeters because this is the magnitude of an earthquake. We don't have units on this. And the only way you would know that there are no units is in part A. We said that the earthquake has a magnitude of 8.3. We didn't give a units there, so it's the same. You don't need the units here. If you wrote what, centimeters? I don't know. That's a good question. And knowing me, I probably would. Because I'm like, super hard teacher. So yeah, it probably is. Okay, any more questions on earthquake types? Okay, Sergio, we good with this? Can you pass it to Lucio, please, Lucio?